Hey folks, in this video we're going to be talking about some reaction equation basics. So what I would like to do is really just go over different types of reactions. Sorry, my brain just... And I want you to be able to name these reactions and distinguish them from each other if you see them all mashed up. Cool. And I want to look at some dogs and some bags. So here's the new vocab we're going to be looking at. We're going to talk about some new types of things like synthesis reactions, decomposition, single replacement. You can read the list. Let's just go on our own. So diving into our reaction types, we're going to start off with a synthesis reaction. A synthesis reaction is where two or more chemicals come together to make one chemical. This would be like A plus B gives us C, or WXY gives us Z. Some real examples would be if you took some solid sodium and some solid chlorine. I don't know how you're going to get a solid single chlorine atom, but whatever. And you mash those together, they'll make NaCl. That is a synthesis. We've taken two things and combined them. We've synthesized something new. Or here's another for realsy example. If we took some gaseous water and some C2H4, we could make some ethanol. Some ethene plus some water, it gives us ethanol. Here we have two chemicals combining to make one. On the other hand, the opposite of this would be a decomposition reaction. This is going to be where one chemical breaks down into two or more chemicals. Decomposition reactions happen a lot in nature when things decompose. Dead stuff breaks apart and it decomposes and breaks into many smaller parts. So in this, one chemical breaks apart into two or more chemicals. And so some real examples that are simple in chemistry would be if you took some calcium carbonate and you heat that stuff, you'll get some calcium oxide and CO2 gas coming off of it. Or if you took water and you zap that with electricity, which you can do with a 9-volt battery if you feel like making some gases, you can turn that into hydrogen gas and oxygen gas. You can decompose it into the two elements it is made of. Neato, well, other reaction types, getting fancier, we have a single replacement reaction. And so this is where when a free element is going to get mixed up with a compound, a binary compound. And this is going to be either ionic or covalent. And so the pure element is going to replace one of the elements in that compound. The element that gets kicked out of the compound, well, it then becomes a neutral free element, like the dude who jumped in and took its place. So an example or the typical formula we might see for this would be like A plus BC gives us AC plus D, or sometimes the free element gets listed first. It doesn't really matter what order we put our products in. Either way, we just have to show them. So here, this is shown slightly differently, where we've got, why did I put D in here? That was dumb. Let's look at this picture instead because it's a little bit better, where A and B swap places. So this shows probably cations replacing each other. And so here's a for realsy example. We might see some solid lithium getting mixed up with some gold nitrate. It'll kick out that gold and give us some precious solid gold. That's nice. Or an example of a nonmetal doing this, if we took chlorine gas and we mix that up with some lithium bromide, that chlorine would jump in and kick out that bromine, giving us bromine as a liquid bromine, and lithium chloride. Nifty, well, like a single, wow, look at that dog with its head in a bag. Look at that dog with its head in a bag. And this is a doggo who thinks it's a cat, and this dog wins. This dog is winning it head and bag. Anyway, we had a single replacement reaction. Well, we also have a double replacement reaction. And this is going to be when we have two aqueous ionic compounds that are dissolved in water, and they're going to trade cations. And so one of these new compounds that are going to be formed from the trading is going to be non-aqueous. Typically, that's going to form a solid. So you're going to mix two ionic compounds that are dissolved, and a solid is going to precipitate out. Though we can also form liquids and gases. And so our typical formula might look like something like this, where we have AB plus CD, two ionic compounds, a cation and an anion, anion. And you can see our cations are going to trade places. So now we've got them with some new partners. Here's a for realsy example. We could take sodium hydroxide and mix that with iron chloride, iron 3 chloride, and that would give us iron hydroxide, which, you know what? This shouldn't be AQ. That should be solid. Let's fix that. Cool. Or another for realsy example is we might take silver nitrate and aluminum bromide, and that aluminum bromide is going to stay nice and dissolved, but silver nitrate will precipitate out as a solid. Silver bromide is not very good at being dissolved. And so this is going to include reactions like acid-base reactions. When you take an acid and you mix it with a base, you're going to get a salt and water. It's also going to generate a lot of heat. And so an example would be if you took some hydrochloric acid and mixed it with sodium hydroxide, the H is going to swap over to this OH, and the Na is going to swap over to the Cl. So we've got NaCl and HOH. Well, you know what? HOH is the exact same thing as water. So we're always going to form a salt from our cation and anion that are part of the acid and base, and water. For real, the example, if you took some phosphoric acid and you mix that with some calcium hydroxide, you would make calcium phosphate, which would be a solid actually, and some water. And we'll learn how to figure out if ionic compounds are going to be solid or not in a later video. Cool, we'll move on with our reaction types. We've got combustion reactions. This is things burning, a fire. And this is typically, when we talk about it at least, going to happen between a hydrocarbon and oxygen. Those are going to combine to form CO2 and water. A hydrocarbon is just a compound that's made of hydrogen and carbon. Hydrogen, carbon. And so, yeah, a combustion reaction is fire. When you are burning things, that is a combustion reaction taking place. And so we're going to use, when we're talking about hydrocarbons, this typical formula. We've got CX, this should probably be HY, because those will be different, combining with water, or oxygen, sorry, to give us CO2 and water. And I've left blank spots for I'm messing up all over the place. I've left blank spots for coefficients so that we can potentially fill those in, because depending on the hydrocarbon you're burning, you will have different ratios of elements combining and products being formed. So for reals, the example is you might take methane gas and burn that with 2 moles of oxygen, 1 mole of methane to 2 moles of oxygen gas, and that'll make some CO2 or H2O. Or another example where we've got some much more intense coefficients is if you were to burn C6H6, which say that's hexane, and that's going to need a lot more oxygen and produce a lot more CO2 and H2O. Cool beans. Well, even fancier reactions that also generate a lot of heat. Remember, combustion reactions, when you burn stuff, generates heat. Nuclear reactions are going to generate heat as well. That's why a nuclear power plant works. And so a nuclear reaction is very cool because it is unlike these other reactions in that it involves the nucleus of an atom. In all the other reactions we've gone over, this is all really dealing with electrons jumping between things and always trying to form that octet. But in a nuclear reaction, we're studying the nucleus of the atom. And this nuclei, these nuclei that we're studying, are going to emit particles or energy. And so whenever we are writing out nuclear reactions, you're going to be able to distinguish them because they will have the full nuclide symbols for our reaction, or for the elements in the reaction. So here we don't have our mass number or atomic number on our different elements, but you will see those in nuclear reactions. And so they're going to be there because we're going to have changes in atomic number and also mass number when we're doing nuclear reactions. More on that in a later video. But they're really cool because we can frequently turn one element into a different element, kind of like alchemists. So I think nuclear chemistry is pretty dope. But anyway, that's the end of this video. I hope that you can name different types of reactions and identify those different types of reactions if you see them mushed up with other types. Anyway, ta-ta, have a great rest of your life.